Hi, so for today we're going to talk about variation of parameters of solving second order differential equations. And I would not be dealing with the derivation on how to solve second order using variation of parameters, but rather I'll be giving you the formulas to remember in solving a second order differential equation using variation of parameters. So let's get started. So from this, we have the formulas to remember. We have u sub 1 prime is now equal to w sub 1 over w, where w is actually the Wronskian. Okay, it is very, Wronskian is not so familiar, but if we want to get the Wronskian, it's actually given by this. Okay, it's the determinant of a row 1 and row 2, a 2 by 2 matrix wherein we have y sub 1, y sub 2, and we have the second row consists of the derivative of the y sub 1, in which this is denoted as y sub 1 prime, and of course the second row with the second column would be y sub 2 prime, and then get the determinant. That's basically the Wronskian. Okay, so that's given by W. Okay, so we have u sub 2 prime is equal to W sub 2 over W. Okay, so this is basically Kramer's rule. Okay, this is only Kramer's rule. We have Wronskian sub 1 over the Wronskian, and we have Wronskian sub 2 over the Wronskian. So if remember in our matrix, if we are getting the unknowns of the, for example, a two equations, two unknowns, and we're going to get the uh, unknowns by Kramer's rule, we may recall that we are simply replacing, okay, for example, in our Wronskian, these are the constants. In Wronskian 1, we are going to replace the first, okay, the first column by the constant. So you can imagine that this is our first equation and our second equation. Okay? So we are going to replace the constant, okay, 0 and f of x in this case, okay, the first column of w sub 1, and get the determinant. Okay, that's w sub 1. And for w sub 2, you're going to copy the y sub 1 and y prime sub 1, okay, y sub 1 prime, okay, and then replace the second column by the constants, of which this is 0 and f of x. Actually, this is where we get our formula. Okay, so it takes time, but as we go on to solve some problems, okay, you will understand deeper what that, or appreciate more this formula. So let's get started. I will show you how to solve a second order differential equation by variation of parameters step by step. Okay, so we're going to solve this. Solve y double prime minus 4y prime plus 4y is equal to quantity x plus 1 multiplied by e raised to 2x. Okay? So the very first thing we're going to do here is to write the auxiliary equation. Okay? Write the auxiliary equation. Auxiliary equation. Okay, we know that we can replace this by m squared because it's second derivative, and then we have minus 4m plus 4 equal 0. Okay? Remember that whatever it is on the right side, okay, this is our f of x. This is considered as constant, okay, because we have a dependent variable of y, and this one is all in terms of x, so this is constant. Okay, so we have f of x. That is our f of x. So for our auxiliary equation, we're going to get the roots. Okay, and we know that that is equal to m minus 2 squared equals 0. So we have a root m sub 1 and m sub 2, which are both equal to 2. Okay, then we have m sub 2. So this is a repeating root. Okay, if you haven't watched my discussion, okay, about auxiliary equation with repeating roots, might as well first watch that before proceeding with this video, because it's we're going to apply what we have learned on that video. So it is a repeating root. So Therefore, its characteristic equation or y sub c can be now rewritten as, since it is repeating, we have c sub 1, okay, we have e raised to m sub 1 x, okay, which is 2, plus c sub 2, and then we have x because it's repeating, e raised to m sub 2 x. So this is now our characteristic equation. Okay? So, from here, we can get y sub 1 and y sub 2. Okay? In this case, this would be our y sub 1. This would be our y sub 2. So, what we're going to do next is to get the Wronskian. Okay? First, the Wronskian. Again, in order for us to get the Wronskian, okay, we can rewrite it as e raised to 2x and x e raised to 2x. The Wronskian of that is actually the determinant, okay, the determinant of y sub 1 and y sub 2 from our formula. Okay, this is that, y sub 1 and y sub 2. So we have e raised to 2x, then we have x e raised to 2x. And then the second row would be composed of the derivative of each of these elements. So we have the derivative of this 2e raised to 2x. Then if we differentiate this, this is actually what? This is product rule. So we have 2x e raised to 2x plus e raised to 2x. And then we enclose that by our determinant. Okay? So in getting the determinant, again, we need to get the product, okay, of this diagonal minus the product of this diagonal. Okay? So first, we get e raised to 2x multiplied by 2x e raised to 2x plus e raised to 2x minus the product of these two diagonals. So we have x e raised to 2x multiplied by 2e raised to 2x. So if we evaluate that, that would be 2x. Okay, it becomes e raised to, this become 2x e raised to 4x plus e raised to 4x. Okay, if we multiply this, their exponents add. Okay, so we have minus 2e raised to 2x times this, 2x e raised to 4x. So as you can see, we can cancel out this and this. Hence, we have an answer of e raised to 4x. It's a matter of the loss of exponent. That's why it became 4x. Okay? So we add the exponents. Okay. So that's the Wronskian W. Okay? So again, we need to find, let me just again rewrite W sub 1. What is W sub 1? We're going to replace the first column, this column, by the constants. Okay? And we know that the first constant is 0 based from our equation on the formula. And the second one is the given f of x from our example. So we have x plus 1 e raised to 2x. Okay? And then copy the same column, second column of our Wronskian, of our original Wronskian. So we have x e raised to 2x, then 2x e raised to 2x plus e raised to 2x, then get the determinant. That's the Wronskian W sub 1. Okay? So we know that this is 0. Okay, that's 0 minus this diagonal is 0. Then minus the product of this. So we have x plus 1 e raised to 2x multiplied by x e raised to 2x. So if we are going to simplify this, that should be negative x plus 1. Then we have x e raised to 4x. Okay? And then we simply multiply that. So we have negative x squared e raised to 4x plus x e raised to 4x. Okay? And again, distribute the negative sign. Negative x squared e raised to 4x minus x e raised to 4x. And then factor out some of the, what do you call this? Factors. So e raised to 4x is both common and as well as the negative. we can factor it out. So we have x, okay, plus 1. Then we have e raised to 4x. Okay, that we have x e raised to 4x because we can factor both x here, x e raised to 4x. So that's our w sub 1. How about for w sub 2? Okay, Wronskian sub 2. That is, we simply copy the first column, okay, of the original Wronskian. So we have e raised to 2x all over 2e raised to 2x for our second row, second column, first column, second row. And then we're going to replace the second column by the constant. So we have 0 and f of x, which is x plus 1 e raised to 2x, and get the determinant of that. So upon getting the determinant of that, we know that this is minus 0. Okay? This should be 0. I'll write that later on. So what will happen if we multiply this? This should be e raised to 2x. Okay? And then multiplied by x plus 1 e raised to 2x minus 0. And that is e raised to 4x x plus 1. Okay? That is our Wronskian sub 2, w sub 2. Now, it is time for us to get the u sub 1 prime and the u sub 2 prime. So, how do we get that? Again, from our formula, u sub 1 prime, that is w sub 1 over w. So, we have the w sub 1 as this, negative x plus 1 x e raised to 4x all over the w, which is e raised to 4x. E raised to 4x. Since this is, the numerator is multiplication, we can cancel it out. So, we have the term, okay, negative x times x plus 1, of which that is negative x squared minus x. Okay, that is our u1 prime, u sub 1 prime. How about u sub 1, u sub 2 prime? Okay, so we have w sub 2 over w. So w sub 2 is e raised to 4x, x plus 1 multiplied by x plus 1 all over our w is e raised to 4x. So definitely that would cancel, leaving us x plus 1 for our u sub 1 prime and u sub 2 prime. Okay. That is not the final answer. What are we going to do is to integrate u sub 1 prime and u sub 2 prime. So that it becomes u sub 1 and u sub 2. So if we integrate, okay, u sub 1 prime and integrate u sub 2 prime, well, of course, it is in terms of x. So if we integrate that in terms of x, okay, in terms of x, so what will happen? We know that the answer is very easy. It's just a power rule. Power rule. So we have negative 1/3 x cubed minus 1/2 x squared. Then we have x plus 1 here. We have 1/2, okay, x squared plus x. Okay, that is the integrate or the integral of u1 prime and u sub 2 prime. So this is now equal to u sub 1 and this is now equal to u sub 2. Then what are we going to do next is to get the particular solution. Particular solution. Okay? So we have particular solution wherein we're going to substitute, okay, this u sub 1 and u sub 2, okay, in our characteristic equation, c sub 1 plus c sub 2, as c sub 1 and c sub 2. So this c sub 1 and c sub 2 will now be equal to that of, we get u sub 1 and u sub 2. So what will happen? That is negative 1/3 x cubed minus 1/2 x squared. This is the c sub 1. And this is multiplied by e raised to 2x. Then plus c sub 2, this is our c sub 2, u sub 2. We have 1/2 x squared plus x. And then we have x e raised to 2x. Now, we're going to simplify this. And upon simplifying this, we have negative 1/3 x cubed e raised to 2x minus 1 half x squared e raised to 2x plus 1 half x cubed e raised to 2x, just distribute, plus x squared e raised to 2x. So as you can see, we can simplify 1 half x cubed e raised to 2x and negative 1 third x cubed e raised to 2x, and that is equivalent to 1/6 x cubed e raised to 2x. And as you can see also, negative 1 half x squared e raised to 2x and x squared e raised to 2x can now be simplified as plus 1 half x squared e raised to 2x. Okay? So, hence, this is our result for the particular solution. Hence, therefore, our y, or the solution to our second order differential equation, is the combination of y sub c, the characteristic equation, plus the particular solution y sub p, wherein this should be the answer, c sub 1 e raised to 2x plus c sub 2 e, okay, c sub 2 x, I mean, okay, c sub 2x, c sub 2x e raised to 2x plus 1/6 x cubed e raised to 2x plus 1 half x cubed, or x squared, I mean, that's x squared e raised to 2x. So this is our answer for this particular problem. Okay, I hope you understood or understand that process. So in order for us to really practice more, okay, we need to solve another problem. This will be our last problem for this video. So for number 2, we need to solve the y double prime, 4y double prime, okay, plus 36 equals cosecant of 3x. So if you see a differential equation like this, okay, so the highest order y double prime has a constant greater than 1, okay, so it is good to put this into standard form. So what we need to do is to divide that both sides of the equation by 4, so that we have y double prime plus, okay, we have 9 equals 1/4 cosecant 3x. Okay, so, and again, repeating the process is still the same. The process is still the same. First, we need to get the auxiliary equation. So this is m squared plus 9 equals 0. And we know that the roots of this is imaginary. So our m sub 1 would be 3i, and our m sub 2 would be negative 3i. And we write the auxiliary equations for the complex roots. Okay? So, our characteristic equation, I mean, y sub c would be c sub 1 cosine of 3x plus c sub 2 sine of 3x. This is our characteristic equation. And again, we need to get the Wronskian. Okay? So the Wronskian would be cosine of 3x, this one. And the second row, second column would be sine 3x. And get the derivative of this, that is negative 3 sine 3x. This is 3 cosine of 3x. Get the determinant. So the determinant, again, is this one, the product of this one, minus the product of the other diagonal. So we have, that would be 3 cosine squared 3x, because cosine 3x times cosine 3x is cosine squared 3x. Then we have minus, okay? We have the minus, and the product of this, please be careful with the minus sign, that this minus sign is not the negative one here, so we need to include still the negative here. So we have negative 3 sine squared 3x. Then we have 3 cosine squared 3x plus 3 sine squared 3x. We can factor out 3 because that's common. We have cosine squared 3x plus sine squared 3x. And this is an identity. wherein if we have cosine squared theta plus sine squared theta, that is equal to 1. So we have 3 times 1. This is simply equal to 1. So we have 3 here. Okay, the Wronskian W is 3. Again, the next one, W sub 1, okay, we need to replace the first column, okay, by the constant. And the first constant is 0. And in this case, our f of x is this. Okay? That is our f of x. So we have 1/4 cosecant 3x and copy the second column. So the second column is sine 3x, 3 cosine 3x. So we have sine 3x, 3 cosine 3x. We know that this would be 0. So that is a 0 minus the product of this. So we have 1/4 cosecant 3x multiplied by sine 3x. By using some identities, inverse identity, this negative 1/4 cosecant is now equal to 1 over sine 3x and multiplied by the sine 3x. So simply this would cancel. So we have a W sub 1 or Wronskian as negative 1 over 4 or negative 1/4. And finally, we have W sub 2, okay, as we are going to replace the second column, okay, by the constants. So we have cosine 3x, and then we have negative 3 sine 3x, and then we have 0, then we have 1/4 cosecant 3x. Okay, so we have 1/4 cosecant 3x multiplied by cosine 3x. Okay, so I would just use the identity here. That would become 1/4. So cosine 3x all over. That would become cosine 3x all over the sine of 3x. And get the u sub 1 prime, which is w sub 1 over w. W sub 1 is negative 1/4 all over w. Our w is 3. Okay, so that would be negative 1 over 12. That's our u sub 1 prime. And then u sub 2 prime would be w sub 2 all over w. Okay, so we have 1/4 cosine 3x all over sine 3x all over 3. Okay, so what will happen? We have 1 over 12 of the cosine of 3x all over sine 3x. Okay, so again, what are we going to do is to get u sub 1 by integrating this u sub 1 prime. So we have negative 1/12. Okay, since this uses an x, so this should be dx. So we have an answer to integrate this as negative 1 over 12x. Then we have for u sub 2 prime. Okay, then we have to integrate 1 over 12 cosine 3x sine 3x, okay, dx. So we can factor out the constant 1 over 12. Then we have cosine 3x over sine 3x dx. We can use u substitution by letting u as sine 3x. Our du would be 3 cosine 3x. So we don't have any 3 here. So we will be having what? We'll be having, we have to offset 3 here. If we offset 3 on the numerator, then on outside of the integral, it should be 1/3, the reciprocal. So that we can proceed with the direct, what? Integral of that. So this would become du over u, and that is 1 over 36 ln of the absolute value of u, wherein our u is equal to sine 3x. So we have 1 over 36 sine or ln of the absolute value of sine 3x. So we got already values for u sub 1 and u sub 2. So we now want to get the y sub p, or the particular solution. Okay, so we have to replace, this would become the c sub 1 and this is the c sub 2, which is also equal, this is to u sub 1 and this is also u sub 2, this one. Okay, we simply substitute that. We have negative 1 over 12x. Okay, what is our characteristic equation? Y sub c? Cosine 3x. So we have the cosine 3x plus 1 over 36 ln of sine 3x. Okay, sine 3x, if I'm not mistaken. It is sine 3x. Okay. So, our solution would be the combination of the particular plus the characteristic equation. Let's give first the characteristics. So, we have c sub 1 cosine 3x plus c sub 2 sine 3x. We have minus 1 over 12x cosine 3x. Okay, and then plus 1 over 36. Okay. Sine 3x, sine of 3x, okay, this is multiplied to ln of the absolute value of the sine 3x. So this is our solution for second order differential equation on question number 2. So again, if you learned something for this video, for today's video, about the variation of parameters, please don't forget to subscribe to my channel. So, or if you are new to my channel, so please don't forget to subscribe to get the latest uploads all about the math and engineering tutorials. Again, this is Engineer Abat. Thank you so much for listening. God bless you all.